Slopes of linear functions. So it says here, linear functions show relationships with constant rates of change, meaning for every increase in x, the output, either y or fx, increases by a constant amount. This is often referred to as slope, represented by the letter m. So I know you've dealt with slope in the past. So as we get into linear functions, we just need to review this a little bit to make sure you're sharp with your skills with slope. So really the base definition of slope is like to get this unit rate that we're always kind of looking for is to do the rise divided by the run, which is basically our change in our y divided by our change in our x. And there's also this little formula that you've probably worked with in the past that you can use as well. And I usually use that formula more often when I'm dealing with coordinate points. Now from tables and graphs, I kind of just stay with the rise over run concept. But you can use that as well. So let's get down to number one. It says calculate the slopes of a line that goes through the following 2 points. So if you think of it conceptually, like for instance, I just think, okay, rise divided by run. Now, don't write what I'm about to write, but I say, okay, it's going from 9 to 27. That's our y, right? That's our output. That's our y. From 9 to 27, it's going up 18. So don't write this, but it's going up 18. If I subtract those, I would get 18. And then the run from 2 to 5, how it's going horizontally. So vertically, it's going up 18. And then horizontally, it's just 2 to 5. It's going 3. 18 divided by 3 is 6. So like that's how I kind of like think of it sometimes. And that's some way you can think of it. Just think rise over run. Or you can, memorize this formula I've highlighted, and that's what I'm going to show you here. So if you're using the formula, this is how you do it. I would call this coordinate x1, y1, because that's my first coordinate I see, and this one would be x2, y2. So then I would go, okay, y2 minus y1's on top. Y2 is 27. Y1 is 9. And then the denominator, I have x2 minus x1. So I have 5 minus 2. 27 minus 9 is 18. 5 minus 2 is 3. Slope is 6. So that's how you use the formula to do it. But hopefully you understand what the kind of formula is saying. We're trying to find the change in y, so we're subtracting the y's. And then we're trying to find the change in x, so we're subtracting the x's, and then we're dividing them to get that slope. So let me just show you one more. That's x1, y1, x2, y2. So I'm going to say negative 21 minus 7, 6 minus negative 1. That'd be negative 28 over 6 minus negative 1, 7. That's negative 4. So that's how you apply the formula. And like, again, rise over run. If I think from here to here, this is going down 28 as our rise. And then our x's, that's going up 7. So negative 28 divided by 7 is negative 4. So if you can't remember the formula, just think, okay, how much is it going up? How much is it going horizontally? That's how you find your slope. Change in y divided by change in x, rise divided by run. Okay, so I'll let you do the rest on there. Whoa, what happened there? All right, graphs. Now you can use that same method if you want. If you want to use a formula, more power to you. You just got to memorize it. So you can pick like points, like I can say, oh, this is 4, 8, and then this is I don't know. This point is at 2, 2, and then you can do x1, y1, x2, y2, and use the same sort of method that we use on the front. But what I like to do instead is just, again, stick to the rise over run. I'm going to pick 2 points. I'll just stay with those. And I think, okay, how much does it rise? Kind of draw a right triangle out of this. It goes from 2 to 8. It's going by like 2s, 2, 4, 6. It's going up 6. So I'm going to write plus positive 6. It's going up 6. And then over 1, 2. It's going from 2 to 4. Over 2. So my slope would be 6 over 2, rise divided by run, which is 3. It's quicker that way. Rise divided by run, change in y divided by change in x. It's quicker that way. other than to do the whole formula that you'd have to memorize. So I'm going to just be careful with these and the scale of the graphs. Like I'm sure you notice this is going by 14s. Okay, I'm going to show you D. So D, maybe I'll start here. That's a point that it crosses nicely. And then it doesn't cross nicely again until like here. Okay, so let's kind of make a right triangle out of this. It goes 7 to 2, and it's going by 1. It's just going down 5. And then this, it's going from 0 to 20. It's going by 5s, 5, 10, 15, 20. This is 20. So the slope, our rise, -5 divided by 20, which typically want to, so -5 divided by 20 is, if you type it in a calculator, you're going to get -0.25, and that's correct. So I'll write that, -0.25. That's our slope. Or, if it's you just simplify that fraction, it's going to be -1/4. And typically you leave it as a fraction. So number 3. Again, we could like pick a couple coordinates. Don't write this, and use the whole formula. That works. Call x1, y1, x2, y2. Again, don't write that, but you could do that. Or quicker would be to, again, just do rise divided by run. So the rise looks like it's going up 4, and this is going just by 1s. So the slope would be the rise divided by the run. 4 divided by 1 is 4. The slope would be, it's going down 10, and this is going by 2s. So rise divided by run, -5 is our slope. That's pretty much all there is to it. Rise divided by run finds you your slope. So I think you'll be able to do these 5 and 6 again. Maybe I'll pick out some points just in case you need the help here. Like let's say here, slope. These are just slope questions, It's like this is going, I think that's just 1, and then this is over, it's going by 2, so 4. Okay, I'll let you this, and then you can find the changes in here. I'll let you do that. I'll do number 4. The number of active players on a popular video game has been decreasing linearly each year since release. In 2018, there were 115,624 active players. By 2021, there were only 64,894 active players. Over that time period, how many active players was that video game losing per year? So I'm gonna write it out kind of like you would with the coordinates. So I'm gonna say in 2018, it was 115,624. And then we had in 2021, 64,894. So over, that's a period of 3 years, right? 2018 to 2021. That's over 3 years. So we're trying to figure out, okay, how many was it losing per year? It's kind of like a unit rate. How much is each year? How much is it losing? So we went from 115,000 about all the way down to 64,000. So that dropped like quite a bit, like almost like 50,000 or something. It dropped over those years. So, but mathematically, I'm just going to kind of use the formula for this. So let's figure out. I'm going to say this is x1, y1, x2, y2. So on the numerator here, we have 64,894. Take away. So this is going to tell us how much it went down in terms of their active players. And then the bottom would be the years. It would be how many years have passed, which we already know is 3. 2021 minus 2018, that's 3 years. Subtract those. And then if I subtract 64,894 minus 115,624, I got negative 50,000, kind of like I was saying earlier. It's going to go down, it went down 50,730 over 3 years. So divide by 3. And I got 16, I guess negative 16,910. So the question is, how many active players was that video game losing per year? That's why it's saying how much is it losing. That's why it's negative. So it's losing 16,910 active players per year. Okay. So I'll let you finish the rest.